Now, I want to make a few comments before we close this module. Let's look at this example, and this is an exercise that I want you to really think about. Now, how many clusters are there, you think, in this picture, and what are these clusters? Naturally, intuitively, how many clusters do you think are there? Well, most of you might have immediately seen, right? So because our brain processes this these structures really quickly, and we should be able to quickly say that these points correspond to one cluster, these points correspond to another cluster. There are these two natural clusters in this data. Now let us say I run the k-means algorithm on this data set, the algorithm that I just described on this data set. What do you think will happen? Well, it's not a trivial question to answer. I want you to pause and think about it, ponder about this. Let me give you two possible options that could happen, right? So, is this going to output the solution on the left, or is this going to output something like a solution on the right? Right. So, in the left, what we have is the natural clustering that we thought will come out, which is the blue versus the red. These are called as two moons data set. You have this moon like this and the moon like this. Will it extract out the correct moons, or will it kind of do something else, right? So it will kind of put a line, and then one on the left is one moon, the ones on the right is, not one moon, one group, the ones on the right is another group. Which one will our algorithm lead to? Now you'll have to think a little bit deeper about the algorithm that I described, and then think about what might come out of this. This is an excellent exercise for you to think about, and it would be fascinating to discuss this in the learning session as well, right? So in the live session as well with the instructors, to see why one of these is what the k-means algorithm will lead to, and which of it is that. So I'm going to not answer that question now, but I would want you to think about that deeply. There are some more questions I would want to end this discussion with, three questions specifically. Now, in the examples that I said, right, so I actually told you what is the value of k that must be chosen. Now, which means that the algorithm needs these pivots, and I tell the algorithm how many pivots, which means that I know how many groups I am looking for in the data. But oftentimes you may not know the number of groups in the data, right? So let's say it's a customer segmentation problem, and I want to figure out how many broad types of customer t-shirt sizes are there. A priori, I don't know there are just three sizes, right? So I might think it's small, medium, large, right? So maybe there is something in between small and medium in the customer segment that I'm targeting. There might be something between medium and large. Maybe there are 5 different types of customers, which means that I need to figure out 5 different t-shirts, right? T-shirt models. Now, the algorithm that I described though requires the choice of k to be given as input. I need to tell the algorithm, hey, give me 5 different clustering, or give me 3 different clustering, and then the algorithm will give you that. Now in general, for every k that I give, the algorithm will give me some output, but which k should I use? How will I choose the k in the k-means algorithm? Think about this. This is a wonderful question to ponder about. This is question number 1. Now, can you think of a real world example other than what we have discussed so far, where you can actually apply the k-means algorithm, or any clustering algorithm for that matter? Can you think of a situation where you have some data and you believe that there are some natural groups in this data, but you don't know what these groups are, and can you come up with a way, can you come up with an example, real life example, that you see in your classrooms or in your peer groups, wherever, right? So I will leave it to your imagination, but can you think of a real world example where a clustering algorithm makes sense? And the third question that I want you to think about is, well, k-means is one algorithm, right? So it's just one algorithm that I told you. There may be some other better way to do this. Maybe I'm sure there are smart school children, 11th standard children, who have fascinating ideas to do clustering other than the one that I just described, right? So can you come up with new ideas of clustering? If so, how would you go about doing this? Well, these are the questions for discussion. I'm sure you will have a fascinating live / demo session in the next week. where these questions will also be pondered upon, and hopefully you will get some exciting answers to these questions and come up with exciting algorithms maybe as well, right? So with that, I would like to conclude module 2, where we discussed the broad paradigms of learning, which included supervised learning, unsupervised learning, and sequential learning. And we did a deep dive into unsupervised learning. We looked at one specific algorithm called the k-means algorithm, and we opened up a lot of questions that one might have to answer before convincing k-means is a good algorithm or a bad algorithm. Coming up next time would be some algorithms for supervised learning, which are super interesting algorithms as well, and that would be in module 3, which you will see next. So I will again see you with some fascinating algorithms for supervised learning in the next module. Till then, happy learning. Thank you.